Basically, yesterday we've learned about index numbers. The concept of index numbers talk about what is the percentage change that happened in the variable, the price, as compared to the base year. But what should be the base year? Something which is, um, similar to the current year, which is not part of a unusual variation. So such a year should be taken as the base year, which is used for comparison, comparing what changes actually happened and what's the percentage of change. So base year is taken as 100% and the current year is what percentage. So based on that, we have so many situations where only the prices are considered, or the along with the prices, the weights are also considered. Sometimes we see the weights of the base year alone is taken into consideration. Sometimes the weight of the current year is also taken into consideration. So in that situation, how do we calculate the indices is what is we would be looking into. Question number 174. So 174 says that if an index of an average gross earnings with base year 2011 and at constant 2011 prices is calculated to be 107 by 2016, which of the following statement is correct about changes in average gross earnings over this 5 years period? See, the base year here taken is 2011. Okay. The index value is calculated for the year 2016. So from 111 to 2016, there is a time period of 5 years. Done. After that, the index, so base year, whatever is the value, if it is taken as 100%, the prices in 2016 stand at 107%. So which of the following statements is correct about changes in average gross earnings over this 5 years period? A total of 1.07% more goods and services can be bought by average earnings. A total of 7% more goods and services can be bought by average earnings. Earnings have risen by 1.07%. The average price of goods and services has risen by 7%. Okay, so index is 100%. Now they stand at 7%. So in that case, should we go with A? A total of 1.07% more goods and services. See, if it is 107 from 100, if it is 107, the difference is 7%. It is not 1.07. See, if it stands at 107 as compared to the base, which is 100, so the difference is basically 7%. So we should go with that. See, 1.07 cannot be the situation. So the difference what we have is a difference of 7% as compared to the base year. So where we talk about a total of 1.07%, total of 1.07% will not be the case. So we can cancel off these two things. Now, a total of 7% more goods and services can be bought by average earnings, or the average price of goods and services has risen by 7%. So between B and D, we have to choose. Okay. Which of the following statements is correct? So we are going with the correct one. Correct about changes in average gross earnings. Changes in average gross earnings. So how do we decide on that? Is it about the average price of goods and services has risen by 7%? Index numbers indicate that the prices have risen by the percentage. But one more important point which is given in this question. Otherwise, see, when we talk about, when I go to the PPT and come back, all the scribbling will be erased, but doesn't matter. See, we talk about index numbers here. See, if a series of values related to different time periods are expressed as a percentage of the value of particular time, they're called as index numbers. So we talk about index numbers taking the whatever is the price in the base year as compared to the the current year's prices as compared to the base year, and then we talk about, so what is the value, what is the percentage change in the value. Now in this particular question, it has two points. One is about the percentage change in the prices of goods and services. A total of 7% more goods and services can be bought. That is one thing. The prices of goods and services have risen by 7% is another point. The question has one more important point, that at constant 2011 prices, the prices have not risen by um, 7% during this 5 years period. Prices were constant. When the prices are constant, it would be about the index, the increase in the index would be about the goods and services. So now what do we, infer this, the increase of 7%? Is it on account of increase in prices, or is it on account of value of the goods and services? So here it would be, because the prices are constant, the value of goods and services would be the situation. So we go with B, not with D. 175 says that in which of the following ways could a price index of 235 be interpreted? There has been a 35% increase since the base year. There has been a 135% increase since the base year. There has been a 235% increase since the base year. Prices are now 2.35 times what they were in the base year. So what can we select the answer to be as? Are you there, Kavya?
Yes, ma'am.
Okay. So which of the following ways? So it is not only one answer. It is it could be, there is a possibility that it could be multiple answers. So if the price index, it's only the comparison of the prices, price P0 and P1. So in that case, if the index number is 235, 235 can be interpreted as, so the percentage increase over 100 is 135%. So there has been a 135% increase since the base year. That is the that's an answer. If it is in terms of percentages, it is 135%. But if it is taken in decimals, so 100% is 100 by 100 one time. 235 percent will be 235 by 100, 2.35 times. So both of them basically talk about the same thing. So prices are now So prices of 2.35 times means that see, if it is 235%, it will be 235 divided by 100. So in terms of number of times, it will be 2.35 only, no? Divided by 100, it will be 2.35. So the fourth bit is also correct. So on that note, second and four are correct, will be C. C will be correct. One 176 says an inflation index and index numbers of a company's sales for the last year are given below. We have quarter 1, 2, 3, 4. Sales index are given, inflation index are given. Which of the following statements is true? Real sales that is adjusted for inflation are approximately constant and keeping up with inflation, growing steadily and not keeping up with inflation, growing steadily and keeping ahead of inflation, falling steadily and not keeping up with inflation. So real sales, the sales indexes are given, so they have been increasing, and then inflation index also, we can see that there is an increase in inflation index also. In that case, so real sales would be this. These are nominal sales, and the sales index is calculated when inflation is given. So we need to question number 176. We have quarter 1, 2, 3, 4. Then sales index. Then we have inflation index. The question is talking about what is real sales. So let's find out real sales index. Sales index are 109 here, 120 here, 132 here, and then 145. Then comes inflation index is 100, 110, 121, and 130. When inflation, what would be the base in inflation index and index numbers of companies? Here are given below. If inflation, the price rise is the appropriate okay. See, inflation talks about the rise in prices. See, when the inflation is increasing, the inflation index is increasing at 100, 110, 121, 133. So when inflation is increasing at this rate, on par with inflation increase, the sales also should increase. But we don't see both of them are being on par. Now then, in that case, what do? We take the inflation index as the base, that is denoted to 100%. When inflation index is 100%, the real sales should be how much is what we will be looking into. So inflation index, that becomes the base. So if inflation index, which is 100, is taken as 100%, what should be the sales actually be? The real sales should be. The now the sales were at 109. Is what percent? Similarly for everything. So what do we do? Is equal to 109 into 100 divided by. Which of the following statements is true? Real sales that is adjusted for inflation are, what is the scenario? When we look at the calculated value, almost all the 4 quarters, the real sales keeping on track with inflation index, it should be 109, but the actual sales are growing more than the inflation index. So if the inflation index is taken as the base, the real sales should have been 109, but we don't see the real sales to be as 109. It is 109, 120, 130 to 145. They are growing more than the actual sales index is growing more than the increase in the percentage of inflation index. Percentage increase in the inflation index. See, the real sales should be approximately constant and keeping up with inflation. That should be the real situation. But growing steadily and not keeping up with the inflation, growing steadily and keeping ahead of inflation, falling steadily and not keeping up with inflation. It is not falling. Real sales, the question is about real sales. So are the real sales increasing, decreasing, keeping ahead, or none of them is correct. The real sales, the question is about real sales. So the real sales are constant, approximately constant, keeping up with inflation. If and the sales index are growing at higher pace than at a higher rate than the rise in the inflation index. So that is what we would be taking for 176. One 177 says details of an index number are given below. We see group, there are 3 items: food and drink, travel and leisure, housing. So the base is taken as 100, weights are given, and the index is given. So which of the following is the all items weighted index number closest to 2? Base 100 is given, weights are nothing but the quantities, those things are also given, and the index is calculated. So if we are to find out the weighted average, so weighted average is the sum total of the product of these 2 calculations. So we see there are 3 items: food and drink, travel and leisure, housing. So there are 3 items. The base is already given to us as 100. Then weights are given. If we are asked to find out the weighted average index is take the weights and take the index, multiply both of them, sum total sigma. The formula for weighted average is we would have it as sigma wx divided by sigma W. We have the weights as 50, 30, and then 20. And then we have the index also given. Index are 140, 130, 120. If we take this to be as I, let's put this one as I. So Wi is equal to the product of these two. We also know what sigma W. So weighted index number is equal to weighted index number is equal to 13,300 divided by 100. Is equal to 0.001 is 133. One seventy eight says a weighted average index number is made up of two items, food and non-food items. So question number 178. We have non-food and then we have food. In this question, there is one item of index number missing. Weights are 7, 3, and then this is 10. Index are, we have it as 130. Then for the next one, it's a question mark. But the total of Wx is given as 127. So in this case, we are asked to find out the missing figure. So that is the, for the food item, what's the index number is what we are supposed to calculate. The same logic about weighted average index is equal to weighted average index is equal to 127. In fact, actually the formula says not able to find it. I'll just write sum of WI divided by sum of W. So this is equal to, we would have it as 127 divided by 100. So sum of WI would be, can be taken here as is equal to, there are, open a box bracket, it should be 130 into 7 plus, in bracket, let's put it as X. So X, we'll put it as I into 3. This will be sum of W into I divided by sum of W is what? Sum of W is 10. This value is equal to 1.27, because here we see that 127 by 100 would be 1.27. So when we multiply, when we multiply 130 into 7, check that how much would it be. I'll write 3i is equal to, take everything to the other side, is equal to 10 goes to the other side, 1.27 into 10. Okay. Then this 130 into 7 will be, will go to the other side. This is not 100, it is 10, no? So the point would be 12.7. So we will have this one as 12.7. And here as well, it should be 12.7 into 10 minus 130 into 7. But that will become too much of a negative value, no? See, all items index, it is not the total of, this is the X bar W. I think the placing should not have been here, but sigma X bar W itself is 127. It is not just the sum total. So this part will be weighted average index itself is 127. It is not 127 divided by 10. I made a mistake here. So here it will be 127. So 127 into 10 minus, okay. Now 130 into 7. So I is equal to, so I is equal to, we have it as 120. I is equal to 120. So here the missing index 127 is the final value which is calculated. Sigma W X by sigma W, the entire thing X bar W is itself is 127. So we get the MISIC index number as 120. $179. The price index for a commodity in the current year is 87. Base year is equal to 100. And the current price is $490 per unit. What was the price in the base year to the nearest cent? The price index for a commodity in 87 is 87. Base year it was 100. And the current price is 490 per unit. In the base year. Okay. So proportionately we adjust that. The logic would go like this. See the base year when it was 100. We don't know what is the price. The current year, now when it stands at 87 and the price is 490. So what is this? We have 490 into 100 divided by 87. I will also write this calculation here so that it will be there. 179, question number 179. Base year is taken to be as 100 and this is price. In the base year, the price was, don't know. The current year, you can only write current. The current year, when it is at 87, the price stands at 490. Do the cross multiplication. So price in base year is equal to is equal to 490 into 100 divided by 87. If a price index is 102, which two of the following statements are correct about average prices? So price index is 102. I think a similar question we have done 235 thing, the same thing. Prices have risen by 102% since the base year. Prices are now 1.02 times their base year. Prices have risen by 2% since the base year. 235% also we've done. See, if it is 102, it indicates, see, 102% is 102. The difference between 102 and 100 is 2%. In terms of percentage, if we talk about, we just have to talk about the difference, that is 2%. So anywhere, if it is 2%, we go with that. It is not 102% because the difference in the prices, I mean, the difference in the base value and the current value. So the current value, if it stands at a particular value, the difference would be the change in the prices. So from 100, it now has increased to 102. So the percentage increases 2%. The same thing if we are to find out in terms of a decimal value, so it would be 102 divided by 100, which is equal to 1.02. Okay, a similar question just now we have answered. So where we see it is 2% rise, that is C. Okay, in terms of the number of times, 102 by 100 is 1.02. So B is also correct. So B and C are the correct answers for this one. Then 181 says magnetize uses material X in their production process daily. 2 years ago, the price index approximate to the cost of material X has had a value of 120. It now has a value of 160. If material X costs 2000 per kg today, what would its cost have been 2 years ago? Logic also, just now what we have done, the base year price. So in a similar situation, we will also be doing it now. See, the 2 years ago, the price index approximate to cost of material had a value of 120. So 2 years back, so the base year, in that year, the index, if it stood at 120, we do not know what's the price. But in the current year now, it stands at 160, and with 160, the material cost is 2000. So what was the cost then? So that is what is the logic. So let's do this one. 181. 2 years back, we have price index and then material cost. So 2 years back. So 2 years back, the price index was 120. We do not know what's the cost of material. Now, current year, the index stands at 160, and the price of the material cost is 2000. So, cost of material 2 years back is equal to, it would be 120 into 2000 divided by 160 is equal to 1500. So 1500 is the answer. Let's go back to the PPT. Last but one chapter, this chapter and one more chapter we have, and if we do that, so that will be the case. So we would be winding up the syllabus. So in any case, tomorrow will be the last class. When data is collected, see, the whole purpose of collection of data, see, the paper focuses on what we have initially started with economics. So the concept of economics at the macro level, micro level, the organization wise. So then, see, basically the decisions have to be taken. If decisions have to be taken for the organization to be benefited, then the data has to be collected. So we were focusing for the past few days about how data is collected, and then the data is processed into information. That's all. In the past few classes, we've been focusing on that. So then once the data is collected, this data has to be analyzed. The mere collection of data is absolutely of no use. Only when the data is processed, some valuable analysis can be drawn out of that. Otherwise, it's of absolutely no use. So um, now, if the data has to be analyzed, the first, the among the data, whatever are the variables. So the data which is collected for different variables, whether there is any relationship between them or not is one aspect which has to be looked into. Are they interrelated? Are they associated with each other? Is there any kind of a relationship which exists between these two? I mean, when we multiple variables would be there, so try to establish whether there is any kind of a relationship. Are they correlated? Are they connected? Is one the behavior of one variable dependent on the behavior of other variable, etc. That all would be taken up as part of analysis. The data that is collected, processed into information, this information has to be analyzed. What is the meaning of analysis? Try to understand what is the data, what is the trend of the data, the pattern, the structure of the data. Then look for, if at all, if there is any association between the variables of the data. So how to understand if there is an association between the variables of the data? So yesterday I have explained to you the concept of big data. See, when the data is captured from transmitted sources, the size of the data has become very big in size. So when it is big in size, then analyzing this big data is an issue there. So the conventional ways of analyzing through the standard computers, it is not possible to analyze that large volume of data. But of course, the big data analysis tools, softwares are available which can even process or analyze large volume of data. So the characteristics also I have discussed. That is the first thing is the volume is big, the velocity, the speed with which the data is processed is quite high. Variety of data is collected, but the data that is collected has to be validated for its genuinity. So those are the characteristics of big data. Now, as part of identifying, if at all, if there is any association between the variables, there is a tool which is used in statistics or business mathematics, what we call it as finding out the correlation coefficient, which is denoted by R. So R talks about, are the variables that are selected, whether they are related or not, whether they are correlated or not is what has to be found out in case of um, correlation coefficient. So with the help of correlation coefficient, there is an attempt made to understand whether they are uh, correlated or not. See, there is a formula given here. Just have to memorize that. If there are two variables x and y, so we have a variable x and we have a variable y. The data for variable x and the data for variable y is taken up for a period of time, and by using this formula, that is multiply x and y, then it would become x and y. So find out the sum total of xy. Here this is sigma xy. Then the sum total of the variable x would be sigma x. This would be sigma x. Then the sum total of variable y will be sigma y. Okay, so the variables n is multiplied into sigma x xy. Then individually sigma x and sigma y. The whole thing divided by under root, we have n into x square. So x should be found out as x square. Then y also would be found out as y square. N into x square minus x bar square. The whole thing into n into sigma y square minus x sigma y whole square. So using this formula, we calculate the value of R. Now, how do we interpret after the calculation is done? Interpretation of R. See, if R is positive, the positive R means Y increases as X increases. Negative R means if Y decreases as X increases. So the variable R, see, if it is if it is plus or minus 1. So it lies between plus or minus 1, then we see that there is a relationship. If it is, then that is a straight line. Either it is upward rising or downward falling, but it is a perfect straight line. If it lies at 0 or close to 0, we see that there is no relationship between the variables x and y. So the interpretation of R says that plus 1 or minus 1 is a perfect straight line. Plus 1 is positive, so it increases as one variable increases, the other variable also increases. If it is minus 1, if one variable is increasing, the other variable decreases. That's the how we interpret that. So that is a negative correlation. Let's say if it is plus or minus 0.09, would be an extremely strong linear relationship, which means that it is closer to 1. So the values lie between minus 1, see minus 1 on a scale from minus 1 till plus 1. So as they are closer to 1 or minus 1, then we see if we can state that there is a relationship between two variables if the value is plus 1 or if the value is minus 1. In both the cases, we see that there is a relationship. Either if it is plus 1, it is a strong positive relationship. It is minus 1, it is a strong negative relationship. But still there is a relationship. See, any value which is closer to 1 indicates their relationship uh, between the variables. As they move away from 1, so they may come closer to 0. Between these two values is the value 0. So 0 indicates that there is no relationship. As they move away from 1, minus 1 or plus 1, they come closer to 0. As they approach 0, the relationship becomes weaker. As they reach 0, there is no relationship. That is how we interpret. Well, what kind of a relationship is there? So can we establish a forecasting equation, a linear equation to forecast the data for future? Depends on what is the value of R. What are the limitations of correlation coefficient? The values of R calculated is only valid within the range of the data used. Sample values less than 10 cannot be relied upon. Links can be accidental or spurious, often because both x and y are linked to some unknown third variable. Therefore, the pattern could be seen because of the change, because both of them are linked to a third variable. That's why we can see that there is change in one variable has resulted in change in another variable. High correlation does not prove that x causes y, but it could be evidence to that effect. Okay, so there are few limitations also. We can depend on this when the sample size is more than 10. For smaller numbers of sample, the number of items in the data, then it is not reliable. That is what is the interpretation of that. Then we have a term called as coefficient of determination. Coefficient of correlation is given as R. Coefficient of determination is given by R square. The coefficient of determination is given by R square. Okay, remember this formula. It gives the percentage of variations in Y, which can be explained mathematically by corresponding variations in X. How do we interpret that? The interpretation says that if correlation between sales and advertising expenditure were 0.9, then R square is 0.81 or 81% of the variation in the sales from 1 year to the next year. Okay. R indicates the relationship. R square talks about the percentage of variation. It says that it gives the percentage of variations in Y, which can be explained by the corresponding variations in X. So if there are variations in one variable and corresponding variation is see, when we talk about a sample or a set of data, let's put this one as a data. if we talk about the average value indicates that somewhere the data, see average value, if it falls somewhere here, it indicates that see almost all, not all of them, but most of them lie around that average value. That is the meaning of that. What does it mean by a variation? In this data set, one uh, value could be as far away as something like this. See, if a class of students, 100 students are there, and the average mark is 80 in a particular subject, so it means that most of them have scored marks which are closer to 80. It doesn't rule away the possibility that someone must have scored 100 marks. So that is a variation that is away from 80. Somebody must have also scored marks of 40 also. When we say that the average is 80, it doesn't rule out that there could be some other possibilities. So there is a possibility that some other variable also could be there. So if that is the situation, um if we are talking about that situation, um so it basically we also have to take into consideration what is the variation. Suppose a firm has an average profit of 10,000. So average profit of 10,000 over a period of time, we can say that it is 10,000. It doesn't mean to say that there would be no amount of loss. There could be also a possibility of having a loss of 2,000 or anything, correct, for that matter. Or there could be a higher profit more than 10,000 also. So those parts talk about what is the variation. What is the variation in the calculated value. So when we consider the variation, so we are not just going by what is on an average, but we are also looking at what possibility or what is the percentage of chances that the value could be anything other than the average value. Okay. So now here, coefficient of correlation is talking about the relationship between the variables. So if it is close to 1, there is a strong relationship. But we should not only go by that, we should also consider the possibility, the percentage of chances that there could be a variation also. Okay. As much as the correlation R indicates 0.9, we should also consider about the possibility of a variation because of variation in one variable, what variation could be there in the other variable, which is expressed by coefficient of determination. So the percentage of variation is explained as 81% of the variation in the sales from 1 year to the next year could be explained by corresponding variations in advertising. So as the amount of advertising, this here in this example, sales is dependent on the amount of advertising. As there is a variation, as there is a change in advertisement happening, the percentage of change in sales also will be affected to that extent. So if advertisement changes by a particular percentage, proportionately to that extent, the percentage change in sales also happens. Now that can be explained to the extent of 81%. So coefficient of determination, we can talk about, see, by a change in one variable happening, what is the possible change that can happen to the other variable can be measured with the help of coefficient of determination. So we are considering the variation, the percentage of variations in one variable impact, having an impact on the percentage change in the other variable. That is coefficient of determination R square. There's another method called as a rank correlation. So the correlations are calculated. See, the variable, whatever is the variable which is taken for study, those variables are ranked in the order of ascending or descending. So first they are arranged and they are ranked. And with the formula of rank correlation, R is equal to, there is a formula given as 1 minus 6 sigma d square by n into n square minus 1. With the help of this formula, we can calculate what is rank correlation coefficient. So R is equal to See, there is an example given. I'll erase the screen. There is an example given here. We see rank X rank in test 1, Y rank in test 2. So when the ranks are given, find out the deviation in the ranks. So D will be the deviation in the rank, 1 minus 3, 2 minus 2, 3 minus 1, 4 minus 5 in the example, 5 minus 4. So find out to eliminate any kind of a negative impact, square it up, and then take 6 sigma D square 1 minus 6 sigma d square by n into n square minus 1. So that will give us as what is rank correlation. Then interpretation of R. How do we interpret that? Interpretation of R is the same as for R. The way coefficient of correlation is calculated, the value of R lies between -1 and +1. As they are close to -1 or +1, the relationship is strong. But when they move away from 1 or +1 or -1, we see that the relationship becomes weaker as much as when it reaches 0, there is no relationship between the variables. So that is what is the interpretation. Okay. Shared ranks, two equal values in the fourth place will both be ranked as 4.5. So the average of fourth and fifth. So if both of them have equal value, so same would be there. Three equal values at the fourth place would all be ranked as 5 instead of 4. Fourth, fifth, and sixth, that's the middle value. So the same rank 5 will be given to fourth one, fifth one, sixth one. All of them are basically formula based. Then once the relationship is calculated, the relationship can be expressed in a linear form wherein it can be used for forecasting in future. So the linear relationship basically talks about y is equal to a plus bx, wherein y is dependent on a variable called as x. Then there are two variables which are a and b. They are to be taken into consideration. So how do we calculate a and b? So a is equal to, we have the constants that are calculated. If there is a linear relationship between x and y, shown by a scatter diagram. Shown by a scatter diagram or by R, the best possible line to fit the data is called the regression line of y on x. So y is dependent on x. Y is a dependent variable, x is an independent variable. Its equation is equal to y is equal to a plus bx. So the variable b can be calculated as n into sigma xy minus sigma x sigma y by n into sigma x square minus sigma x whole square. And a is equal to y minus bx. So the bar over the x and y means to take the mean or the average of x and y. So formula, we just have to substitute. So y is equal to a when x is equal to 0. So 0 into b is equal to 0. So y will become a. Okay. Then if x increases by 1 unit, y increases by b. So 1, whatever is that, this into this value. Okay. Geometrically, b is the slope of the line. So this is called, a is called as the intercept, b is called as the slope. Just remember the terms. Which variable to call x on which and which y. Y is the variable to be estimated because it is dependent on x. Y is perhaps dependent on x. X is often called the independent variable because this is not dependent on anything. Independent variable, and the y is the dependent variable. So let's work out questions from that, and we will have the last topic, forecasting techniques. So tomorrow it should be done in all sense. Okay. We'll work out a few questions, or we'll wind it up here so we can finish up tomorrow.
Anything is fine, ma'am.
Are your other subject video recordings uploaded?
Sorry, ma'am.
For the other subjects, the video recordings, are they uploaded in LMS?
I don't know, ma'am. I don't watch it in LMS since I attend the live classes.
Okay. I'm just pasting the questions in the Excel.
Ma'am, can I take 2 minutes break? I'll just use wash.
We'll continue tomorrow because it's almost true.
Yeah, that is also fine.
Okay. Fine. Let's meet tomorrow.
Okay.
Good day.
Okay. Bye.